Okay, thank you so much. We begin recording. Welcome to a January session meetup. Like today, we are going to talk about relational databases. We are going to talk about demystifying. My name is Yury. I'm director of R&D at Dirigent. Quick introduction about myself. I'm software architect, engineer, efficiency evangelist. 10 years of experience as a manager, as a leader, and 20 years in the industry. Attention. It's quite advanced topic. Like I really appreciate if you actively participate in this meetup. I'm going to ask some question. Like you will need to do some actions. Don't be shy. It will be fun. Like, yeah, please. Topic is advanced. Usually this topic is not covered by books. Usually this topic, it's some kind of for Postgres database is chapter number 70 right now. For current version, for 14 version of Postgres, it's about database layout. Some topics covered there, some topics not covered in official documentation. Like what actually is a relational databases? Databases is amazing tool. But I remember when I started developing application. My first application that was somehow related to web. It was very small application. It was like ISP first version. I was trying to do something on Microsoft stack. Like almost immediately I realized, like second day of development, I realized I need to store data. How to store it? I found that I can do it in Microsoft Access. And it was my first database. But in general concept of database, it was introduced like 50 years ago. And just imagine, like these days, like 50 years ago, like IT was totally different. When I was working on this presentation, I was just like, what was like 50 years ago? Just imagine, there is no Silicon Valley. There is no Apple. There is no almost anything. But this concept that was introduced these days already exists. And it's still like it's changing a little bit. There are a lot of improvements in using resources, for example, in using CPU because it's like that databases in the beginning of this century started supporting multi-thread operations, multi-CPU. But these concepts still exist and still works. And it was time of very tiny storages, like I found in 1917, you could buy only like 30 megabytes of storage, and you should store everything there, like operation system, database, like engine, like, and it's just like 30 megabytes. Probably like even like my first machines that I was using had significantly more, like I don't know, like 20 times more size and storage, and it was like long time ago. And of course, because of this tiny storage, databases introduced like principle of normalization of databases. It means like you need to be very efficient on storage, and everything else was kind of secondary question, because companies start accumulating data, but the same at the same time storages were like very small. Just imagine, like, if we had mobile development meetup, and today like you joined me and I start talking about like how to develop for application for this type of devices that was introduced in 1975. There were probably a couple options, just to push button and listen to some tone. Like it's only option. What else might be done by this device? That's it. You can only talk and use it just only for communication. And it's the gap, because if you compare this device with your mobile phone, you will see the difference. But the main concept of databases didn't change. And of course, relational databases have a lot of advantages. it's why like all of us are using them like on daily basis, because each time like when we don't know what we want to implement, when we don't know like scenarios of using, probably we take relational databases because of data accuracy, because you don't have to think about like algorithms that implemented in NoSQL databases like hyperlock lock or Bloom filters that doesn't provide enough accuracy. You don't have to think about data integrity because of transactions. Like you can like all your data is there, like, and it's like when you commit transaction, it's guarantees that data is there. Of course, flexibility, because like you can achieve almost any flexibility that you want. Like you create a table, you change your pattern of usage, you just create a new index, and that's it. It's very, very easy. You don't have to think in advance what will be structure, what will be primary keys, what will be secondary keys. Like it's easy to modify. You don't have to even think like alter table. It's very, very easy. And of course, high security, because databases and data should be very secure nowadays, even more secure than ever. And like our company provides software that helps people to be compliant with many regulations. And today I'm going to talk about myths related to databases. All of these myths related to my experience. Some of them, like some of these myths were created by me many years ago. And I'm going to start from first myth, and this first myth is related to alter table. Like we worked in, I worked in a company, and we had like a really large database, and this database had one table, and like not only one table, it had one table that that was wide, and my task was just to add column, only one column, and this column was like around like 200 in length. It was Warchal column, and it was very easy. I implemented almost in one day, like, and I was absolutely happy. I changed it ISP 3.0 like it was 16 years ago, and I changed the database. I create alter table. I was ready to almost release all the features, but I start talking to my colleagues, and they start asking very weird question about length of rows. I didn't understand what kind of questions they're asking, and it looked like very weird to me. But I realized that I was done something wrong, absolutely wrong. And what happened, I couldn't realize. But after discussion with my colleagues, I start moving in this direction, and I'm going to tell you a story, what kind of myths related to database. Let's begin talking, let's begin from reading files. Actually, when you're working with database, there is no any magic. Like you read your like you store your data in file, first of all. And to read this file, like you need just to use absolutely one of programming language, and you need just to read this data somehow. Or it's Python. Example in Python, of course, probably not too many people trying to write Python databases, but in general, it happens not like that. In general, it's happened by chunk. Because it will be significantly more efficient to read. It's impossible just to read gigabytes of data in memory each time when, for example, user sent request. It happens chunk by chunk, actually, and it's very simple example of reading file in chunks. For databases, these chunks are called pages, and these almost all data is stored in database, stored in pages. It excludes blobs, large binary object, and it's quite small. Do you have any questions? Good. Page size is absolutely different for different type of databases. like for Oracle, for MySQL Server, for Postgres, and MySQL. And our interaction exercise. Yeah, first interaction exercise. I'm waiting for you. Let's try to define what actually default page size for databases. You like any guesses? Like you can write the database name and page size into chat, and couple minutes I will be back. Are you okay?
Yep.
Good.
Did we guess or did we Google?
No. Just like it would be better without Google. Okay. Who else, guys? Yeah. Awesome. Like you're so smart, guys. Like I really like how you think. Actually, it's
yeah, we got like 500 kilo for the page. That's pretty cool.
no idea. And we are here just to talk about solve this problem and tell you about this size. Like if we are done, like first exercise went very well. thanks a lot for supporting and answering all of this question. Usually we quite silent. Yeah, let me switch to the next slide. Actually, it's 8 KB for Oracle, MS SQL Server, and PostgreSQL by default. Of course, you can like change this setting, but it's kind of highly recommended to use this size. And it's 16 KB for MySQL. And actually, if you have a case related to white tables, much better to use MySQL. And like if you start compare performance, you will see that usually for white table, MySQL performs much better. But let's go in depth. Actually, it means database structure looks similar to scan disk. But actually, it's very similar to disk structure, and it makes sense. Database is about storing data first of all, and this data stored in clusters on the like on hardware, and because of that, database is just using this clusters as structures, and when you're reading. Of course, you need to read and write in the same kind of blocks because, like, you're going to optimize your operations. Is it clear? Cool. And let's talk about page structure because page structure is very important to understand why I made my terrible mistake, why my colleagues were disappointed by my skills. Actually, database page structure looks very similar, like for almost all databases. First of all, each database page has header. This header it like has size different size for different databases, but it's quite small actually. It's for just storing system data there. And after that, we have two options. On this slide, you can see how data stored in Postgres database. Postgres implemented such kind of way. You have pointers to row, and after that you have empty space, and after that you have rows. And each time when, for example, you're reading your data on low level, it happens such kind of operation, like you read your chunk of data, you extract data from rows, and and you extract data from rows. And it's very important to talk about like relational databases, usually row oriented. And this concept works for all row oriented databases. If you hear, for example, this database is row oriented, it looks like that on low level. And if you're going to talk a little bit about like MS SQL doesn't have pointer. MS SQL stored data, and because each string has fixed size, and all of this data written in header, but in header of table, not for pages. Like you can easily read your data, understand what kind of data, like what part of page is empty, and you can extend this data. Is it clear? It's the most advanced topic, guys.
I actually have a question about it. Like one question, like in proportions, how much data is like dedicated to the pointers, and how much data is dedicated to the actual raw data in the page?
Pointer is 1 byte.
No, I mean, for example, you have the page of like 8 kilobytes. Like inside this page, how many space is dedicated to pointers? Like in this case, you said that there is an empty space for for future pointers, right? And how many space
like for future pointers plus data, because like if you add pointer, you add data, and you fill your empty space.
Oh, right. So I mean, they are like filled together until the page is full, right?
Yeah, until page is full. And yeah, it's very interesting question from our principal software engineer, Mike.
What is the address space of the pointers? Is it within, like, offset from the beginning of the file, or just within the page?
Excuse me, could you repeat the question one more time?
I guess I'm trying to understand how the pointers are used, and so I framed it as, what is the address space? Is it just offset from the beginning of the page, or offset from the beginning of the file, the database file?
Like it's offset from the beginning of the page, because each page has header. And after that, like header is fixed, absolutely fixed for each page, like for this type of database. And after that, like pointer starting. And all information in database stored in such way. All information, for example, information about tables stored in absolutely the same pages. Very similar pages, not the same, like very similar pages, because it has also some kind of metadata, it has data, but actually everything implemented in these pages. Are we good? Okay, go to the next slide. And when we start talking about like white table, actually white table on physical level looks like this image. It means like we have header, we have pointer, and we have tiny amount of empty space, and we have everything that like data, and like I'm showing case when our row is a little bit less than 8 kilobytes. And when you start reading your database, to read each row, you almost need to reach page for each row, and any request will be much slower. You start reading like page by page by page by page, row by row by row by row. But the most interesting thing happens when we overflow these pages, when we add a little bit more data into this page, and it was my case. It was my case. Like I added a little bit more data. Database doesn't stop working, and even doesn't send you warning like, what are you doing, man? Like you continue using all of the stuff, like you think everything is good before you go to production, or before your colleagues just asking you to talk about your code.
Or before you're trying to read it.
Yeah, and what happened actually my rows became distributed between 2 different pages, and right now for each row my database need to read 2 pages already. But you cannot use this empty space. Unfortunately, you cannot use this empty space for another row. Absolutely, because like in database, in database, all rows are have fixed size, and because of that, like you need to have this empty space, and it means, like in my case, like you can count like 50% of reads is just wasting of time, and all database are very limited by throughput of your HDD, because like when you're trying to read something, throughput matters a lot, and throughput is, especially when you're in 2006, it's not scalable by one click in cloud. You need to you cannot have like any option for provision types. You need to buy HDD and bring them first of all, and it was like huge performance impact, and a result of this like issue, overflow of internal database structures, and performance drop, like 2 times performance drop for any request related to database. It means like we are reading something, we are reading whole row in relational database, and you cannot read only part of row. It means each request became 2 times slower. Is it clear? Is it clear? Good. To conclude with me, database actually its interface on top of your HDD. Pages are blocks, or like a group of blocks on your HDD. When you think about like your application, you need to think on this level. How you're going to read this data? Do you have enough throughput? You need to think about database first of all as about HDD, because actually all requests go to HDD. NoSQL databases. I also would like to talk a little bit about NoSQL databases. And for example, if you start digging in depth NoSQL, you will see absolutely the same approach. Actually, like if you're talking about DynamoDB, DynamoDB has a write capacity unit. It's units that DynamoDB is using for billing. It means each time when you write your record, you build for this record, and this build item is VCU that equals 1 kilobyte of data. And the same stuff happens like for reading your data. This item called RCU, read capacity unit, and read capacity unit has size like 4 kilobytes. Very similar approach, size a little bit different. Cassandra is kind of mostly kind of private cloud on-premise database. I don't know like how to say it better. It's very popular for as distributed storage. It has the same approach. If you start digging in performance improvement for Cassandra, you will see recommended block size 4 kilobytes, and all logic that implement in Cassandra is related to block size on your HDD. It's highly recommended to use a special HDD for Cassandra, a special block size, special file system. Is it clear? Okay, awesome. Myth number 2. Myth number 2 starts from a little bit later after my first myth. I already became significantly more knowledgeable about databases and about how to work, how to build indexes, how to write data. We had quite large database. We had very huge cluster, a lot of Xeons CPU that were loaded by 80% on baseline. We had a huge amount of memory on our database. Again, it was like 14, 16 years ago. Our hardware cost like $100,000. Our licenses on SQL Server, because we use the Microsoft SQL Server, cost like $100,000. Like it was very expensive hardware. And at the same time, our database was quite large. And we were trying to do the best as in software engineers. We were trying to optimize. We were trying to do a lot of different maintenance that we're going to talk a little bit later today. But it didn't help, because when you're kind of on premise, you cannot scale your hardware in such way. You need to order your hardware, and we were growing. We were getting more and more data. And we got a lot of different challenges, and we, like our CTO, found amazing person, and this person called MVP. That meant Microsoft the most valuable professional, like the most valuable Microsoft most valuable professional. It's very similar to like Amazon heroes, I guess. It's people who involved in community, doing a lot of like for building communities. Research experts, absolute expert. Like I personally, I know just only couple people who had such status. Each year it's nomination. It means like you can get this status, you can lose this status. You need to contribute to community a lot. And this person was he was MVP by like SQL Server MVP. As I mentioned, task number 2, we started optimization. This person started optimization. Our baseline was 80% of CPU usage. What was a result of this optimization? It guesses, like it just lottery.
So what was the nature of the optimization?
It's a good question. Like we just hired MVP. We didn't know what kind of optimization he can do. Like, but he definitely not going to do anything with hardware. He's using the same hardware and do some magic. I don't know.
Was it connected with read and write, where you read and where you write?
Yes, very active on read and write. And kind of had replication.
Yeah, I mean, it is well-known pattern, right? You read at one area and you replicate to the you write to one and then you replicate to reads and you read quickly.
Yeah, but this database had both cases. Just because we didn't distribute this load, we used this database for read and writes, and another database like just for reads.
Yes.
You got a very broad range, like from 146.
146, yeah. Like I know country, and I know country of origin. 15%. Okay, good. 60, 70, $1 means 1%. 90%. I really like 1%, Mike. No. Okay, 75. Awesome. I really like your answers. Let's see how it was. Are you bored? All good? No, good. Okay, awesome. And actually, scaling by using CPU memory. When database start using these resources as CPU and memory, when it gets really logs like slow throughput or like high latency, it starts actively using CPU and memory. And as you get more load, you are going to find out that actually it happens sometimes, and because you have multiple transactions that running at the same moment, and in this case like you start using a lot of different resources. For what cases actually CPU and memory use it? Actually, it's used for variables, including tables, because for example, MS SQL allows you to create kind of temporary table in memory as variable, like as database, I guess, yeah, right now as well. Different type of joins, because when you joining your data, we already discussed how data is stored. But for example, when you need to join your data, it still happens not on a file system. It happens in memory. That all databases today, optimizers of databases really love caches, because if database detects that you have a lot of free CPU, free memory, it starts using it just to optimize performance of future requests. Sometimes it has data that you don't need in these caches. It's kind of very tunable. It like depends on database how you can do. And business logic, like business logic also is using a lot of CPU and memory. For example, like you can use for regex. It's one of the complicated scenarios that I would highly not recommend to use do any business logic inside databases. Like for business logic, we have like special layer in our application nowadays. Database, it's better to use just for storage. And what kind of options we have just to scale our database? To scale our database, as you can see, it starts using CPU when you have like slow throughput. But to solve this problem, you need just to increase your throughput to reduce CPU and memory usage. There are different options just optimize it. For example, like vertical partitioning. Depends, like we are going to talk later a bit about this one. Horizontal partitioning, the same. Any increase of throughput, like for example, like what means increase of throughput? It means add new HDD, create file groups in MS SQL, or table spaces in Postgres. Distributed HDD, like as much as you can, or like have provision tie-ups. If you're working in cloud, it's very good option. Do have someone from Amazon, from AWS? No. Yeah, vertical partitioning. Vertical partitioning. What is vertical partitioning? Vertical partitioning, it means like you have one table. This table is quite large, but you have different pattern of usage for different data in this table, and it's highly recommended just to split this table for these scenarios. As soon as as you split these tables. For example, on this picture, you can see that we create two tables for like for employee table. One of them has first name and last name. Another one picture. It's just an example. It might be totally different cases. But before start doing this vertical partitioning, it's not just a kind of random operation. Like you decide, okay, this table has like 5 different tables. We need to store like first as one table, like, and another 3 as another table. It doesn't work like that. Like you need to start using the same approach that we're using today, like for NoSQL databases. You need to understand pattern of usage. You need to understand frequency of usage with data, because it will allow you to do a lot of different tricks. Because like, do you remember my myth number 1 about row? Actually, everything is row. Like, and in this case, like you're reducing row. It means like you on the same page, you're going to store significantly more data, like for one of these tables. And like if this scenario is totally isolated, it significantly increase your throughput. Absolutely significantly increase your throughput. Any question related to vertical partitioning, why we're using and how to use? vertical partitioning?
Do you analyze any kind of, statistics to decide how to break tables, like on usage? I see that some of the data which usually goes together, if somebody requests with data together, you want to put it into another table, I guess, right?
Yes, of course, you analyze statistics. In general, just for this type of analysis is very complicated because not all databases supports everything. You need to actually have your transactions, first of all. You need to stop using asterisks in your request as well. Because it's pretty interesting. Like, for example, just imagine like using asterisks in this request. Even if you use statistics, you're going to get some data. If you have very advanced database, you're going to get statistic for that you used pictures, that you used file name, and you used last name. But at the same time, actually, it's a mistake. Because of that, I highly recommend never use asterisks in your request. Yeah, it's very important. And if your database collected with statistics, it's amazing. But not all databases are advanced. Better to take a look on transaction, take a look on patterns, and understand nature of this data. As soon as you understand nature of data, like it becomes very, very easy task for you. And again, because databases are very, very, very flexible, you are not breaking this data at all. Like you just using join for cases when you need all of this data, like file name and picture together. Okay, horizontal partitioning. It means, like, for example, we split our database by records. It means like we have some kind of set of data, and this data we decide to create partitions by month. It's very, very popular. Why we might have create this partition? Just imagine like we have reporting system and our clients building reports like for the last month. It makes sense that we have partition for by months. In this case, we are going to use the last partition and partition for previous months most of the time, and all other partitions might be archived, might be stored on very slow storages, and it will increase throughput for our database in general. There are a lot of different cases and benefits from horizontal partitioning. It might be, for example, again, related to your customers, because you might create a file group or a table space for your customer. And it also works and allows you to isolate like premium tier clients from just regular one. Is it clear?
Yep.
Good. This stuff is my favorite one. Why? Because before I met this MVP person, I've heard about like all of magic related to vertical partitioning and horizontal partitioning, but I didn't understand all of these ideas about like file groups. And what does it mean, like these file groups? In general, like file group is a set of tables. It's not kind of isolated set of tables. It's part of database. It means if one file group is missed, it means like your database is not operational anymore. Like you have an issue with consistency of data with checksums, and it won't start. But at the same time, it allows you to distribute your data. And just because I'm talking first of all about like on-premise experience, and I'm talking about like some like not managed solutions, like this disk option works very well, and just to scale your load quite cheap. But it also requires you to analyze what kind of table should go with each other, because for example, just imagine like you split your database, you create these files, you during the creation of these files you put to some disk this information. But again, you need to analyze pattern of usage of this data. For example, how often you are going to join these tables. If you're going to join it's often, better to put everything to the same disk. It will work much faster because if you put on these tables to different disks, it will be significantly slower because of interfaces like in your machine. And some, like for some data centers, it might be quite far away located disk. It might be some kind of network operation required just to get this data. Like in general, like you're trying to analyze, reduce latency, and join this data, and it works very, very fast, and it's super efficient. Any questions?
Another question: can you do, let's say, if you want to read a massive amount of data, can you optimize it like this? So you store it like so it reads in parallel. So it reads table 1 and table from one disk and table 3 from another disk, but you locate them in your like physical location close together, but you know, like RAID kind of thing. So is it even a thing?
One more time, could you repeat?
So let's say if I need to read tons of data very fast, right?
Yeah.
But this data is very homogeneous, right?
Yeah.
And can I break it in kind of RAID fashion? Not.
Yeah. Of course you can do it. I said everything depends on nature of your data, and everything depends on nature of your request. Because, for example, you can create, like, you can use these two disks just for horizontal partitioning. You might have the partition in two different file groups, just because like you want to read everything in parallel, and like you definitely understand your use case.
Mm-hmm.
In this case, let's do that.
So endless possibilities, right?
Yeah, almost.
Almost. All right.
Yeah, it depends how you're going to join, but horizontal partitioning together with file groups can increase throughput like very well.
Okay.
Maybe for later, but do you have advice on what combinations of optimizations are actually optimized? Maybe I'm overthinking it, but I'd see if you combine several optimizations, you won't be getting the benefits.
Like you need to combine everything, but you need when you combine everything, like you need to understand use case, because for example, you can understand that it's very complicated to find DBA.
Yeah.
It's very complicated to find DBA, and why? Because they are busy. They are busy with a lot of different databases that already exist in the world, and their work is just combination with different type of optimization and matching workload needs, company needs, request needs with all of different type of optimization. They don't do anything like any other magic. They do just kind of matching. Okay, like for you need to use this and this optimization. Bam. And they are super expensive, like very, very, like they are very, very expensive.
Oh, that sounds good.
Yeah. Can we move to the next slide? Awesome. Answered actually 20%. Just imagine, like we had machine, we had like very expensive machine, very expensive licensing. But after optimization, we realized we don't have to even have this machine because this person, this DBA brought us a lot of like optimization. And actually, this hardware, we should have, like, we could use this hardware for years after this optimization. And because of that, this growing data, this growing usage of data, I would highly recommend to do this analysis, to do optimization, to think all the time when you do any changes related to database. Of course, probably like your impact on improvement of database won't be the same, like from 80 to 20, but like step by step, you will be there by using one approach, another approach, trying, thinking how it works. Like I highly recommend to think about like scaling database, not on CPU and memory level. I highly recommend to think about database as about like HDD, how to scale HDD, how to scale your throughput. And then you will be significantly more successful as a software engineer. And it will cost significantly cheaper because nowadays HDD is almost free if compared to CPU. And the last myth, because I thought we have someone from Amazon, because it's myth that I experiencing right now, and I'm experiencing with using RDS. Myth number 3 is about managed maintenance. When you start using RDS or like any other database or on any cloud, you will see there are not too many options for maintenance. All of them support like automatic minor or major upgrades, and that's it. But just imagine like your database is doing all the time scenarios, insert, delete, insert. It happens all the time. You cannot stop it. Like you have load, you have different cases, and you never know. What kind of this operation mean on low level? Actually, it create remove rows, and you have like empty rows, just because if you check page number 2, it means like there is something missed. And for example, row number 3 and row number 4, between these two rows, you have empty space. And it means like your database becomes significantly less efficient on reading. When you start reading data, you assume that you create a database and you have to read 20 rows, but you're reading just 10 because of these empty spaces inside your databases. And it's a huge problem for performance for database, just because like you know it's how it works. Like you bought new laptop, like, and it works very well. Like 5 years later, you didn't do anything. You like didn't install too much software, but it became slower. It's the same stuff. You just opened some pages in browsed some pages on the web, and you have defragmentation issue with defragmentation on UHDD, and it became slower. The same about database. Like your database becoming slower through the time, just because of this insert delete operations that like you're doing every day, and like you cannot count them. Okay, what's on the image? Please share in chat. It's the last one. It's not the last one. We are going to have one more, but if you know what kind of things on the picture, just share it. Yeah. And even if you don't know. Fragmentation, defragmentation. Yes, defragmentation. Like I know how old all of you. Yeah, because it's defragmentation. Nowadays, no one knows what actually it is. Yeah, it's defragmentation. I made hint. I'm really sorry, but yeah, it's defragmentation. It's defragmentation. By the way, this screenshot I made from Twitch stream. Right now, many people just stream disk defragmentation, and it's so meditative. Like after working day, after hard day, like you can launch this stream and just enjoy defragmentation. And moreover, like so it looks very, very beautiful. Yeah, you can find it on Twitch. It happens 24/7. Yeah. and it's defragmentation. For database, defragmentation is very, very important. Unfortunately, we don't have like anyone from Amazon, but I wrote like for this presentation my user stories. Like I like user stories. I like customer oriented mindset, and like an AWS, as they mentioned, like an Amazon, as they mentioned, like the customer focusing organization. Like my user story, like as a user, I would like to have managed index fragmentation, like because in my opinion, like any manager database should have such option. Index rebuild, because sometimes index defragmentation doesn't help you, and you need to recreate your indices like from scratch, because actually when you recreate your indices from scratch, only these help you to reduce all of your empty spaces. Sort everything by using primary keys, sometimes rebuild indexes like brings like boosting performance like 50%. Statistics rebuild, because like today, like I showed you like this phone from 1970s. Actually, it's not true about databases. Progressing databases are doing a lot of different things. And in my opinion, one of the best things that database does, collecting statistics. Everything that you're doing, actually, it's tracked inside database, and you can read all of this data. It's not transactional log. It's just statistics, and based on this statistic, you can understand, for example, like this table. You requested, for example, like 20 times, and only 1% of cases, you had issue with missed indices on this database. You can extract all of this information, and it's very, very helpful. But sometimes, like this statistics is just outdated, and just for better experiments, for better data, for more clean data, you need just to rebuild the statistics regularly, because like patterns of usage are changing, like because of a lot of tables changes, like a lot of changes in database happens, like transactions happen all the time. Of course, removing unused indices and creating missed indices. It should be part of just regular maintenance. Like I'm pretty sure like such companies as Google, cloud providers can do that, as AWS. All of this data already exists in statistics. We need just to use it and do some kind of automation for all of these processes. It's it, guys. Actually, it's almost an hour of my talk. Conclusion, what I want to say: database is an interface on top of HDD. It's the most important from this talk today. When you're working with rows in database, think about size. You already know this default size. Think about like 8 kilobytes, 16 kilobytes. For example, tomorrow, we are going, for example, to work with some databases. Check size. If you find that this table is white table and is using more length that you expected, like it will be optimization for you. It will be like huge win. When you're scaling, first of all, start from throughput. Throughput for database is everything. Think about the defragmentation and always think about indices. It's it. But before we finish, the last exercise, like if you write name of your favorite database in chat, and we got like 30% of attendance. Right now we have 26 participants. So it means like around 10 people should write. If you 10 people write right now to chat name of favorite database, I'm going to prepare one more talk before the end of the year about indexing strategy and how to work with indexes. Nice. Mike, could you help me to count?
Okay, yeah, sure. So it's around like 5 Postgres. Yeah, I guess the Postgres is a winner here.
ClickHouse, like,
Yeah.
but is it more than 10?
1, 2, 3, 4, 9, 10. Yeah, 10, and Postgres is a winner.
Awesome. It means like I'm going to prepare a presentation about awesome. Okay, nice. It definitely won't be the next meetup. It won't be. I can prepare. But yeah, before the end of the year. And any questions? No questions?
Oh, that was cool.
Awesome. Thank you so much.
Yeah, I have a question. Even though your last question that you had, it's a Postgres is a relational database. Am I correct?
Yes.
And so we're just talking about DynamoDB is NoSQL. So it's really if you're gonna do another one, it's really either gonna do a relational database talk or you're gonna do a NoSQL database talk. So it's two different animals.
Next one, relational databases indexing strategy. Yeah, I totally agree. Like SQL and NoSQL, absolutely different animals. But if you're talking about NoSQL by default, like in kind of, it used to be like that when NoSQL just appeared. There was almost no option just to create indices. And because of that, indices is kind of topic that tightly coupled to relational databases. Yeah, and GCI, LCI in DynamoDB right now it's an option. Cassandra has secondary like indices, but in general, like main approach for NoSQL database. Yeah, you prepare everything in advance. Your storage is very, very cheap. Because it's like huge difference between like SQL databases and NoSQL databases. This is huge difference, like 50 years, like almost 50 years, probably a little bit less, like 40, 50 years difference. And cost of HDD totally changed. Its like size totally changed. Like many NoSQL database appeared during time of cloud file systems, just because I remember when Google, probably the first one, introduced the Google file system. It means like super reliable, or like it might be even S3 was introduced by Amazon. I remember some of them like introduced this stuff, and it became game changer for the industry. Like after this moment, nobody cares about like size. Like okay, movie like 20 terabytes, like go there, like we can store it. Yeah, size is not a problem nowadays. Any other questions? Yeah, thank you so much.
Yeah, there is a question in the chat actually.
Yeah, I think it's more related to vertical partitioning and normalization.
Okay, yeah, I can explain normalization and partitioning. Like, it's not a problem. Normalization, it means we don't store this data twice. It's kind of main approach of normalization. And in this case, in the original table, you see we didn't store it. Because the main principle of normalization, it means like you don't need to duplicate your data. It's the main task for normalization. It means, for example, just imagine like you have status for for this employee, and you don't store text status for this employee in each record. For example, on vacation, in the office, remote worker. You don't store it for each record. You create a dictionary. You create dictionary, and you store just ID for each employee. It's called normalization. But when we start talking about partitioning, we already don't have such cases. And what we want to do, we are trying to think about like, what is use case? What is use case for this data? Like how we can increase throughput of this data. Yeah, and it's a difference. Is it clear enough?
I think actually in this particular case, it actually becomes a little bit denormalized because you store employee ID twice.
Yeah, like, yeah, if you think about storing ideas like denormalization.
Well, I mean, a little bit.
yeah, exactly. Like, but you're totally right, Mike. Actually, it's becoming even more normalized in this case, but it's optimized just by throughput. Awesome. Cool. Thank you so much for joining. If you have any question, you can find me by using this URL 100xengineer.com. It's me. Please welcome. Like if you have any messages, if you have any questions, you can follow up. Yeah, it's it. I'm going to stop recording. Thank you so much, and we have